Hello everyone and welcome to my channel IB Methodology, your space for mastering IBDP mathematics. So in today's video we are going to solve AAHL May 2025 paper 1. So let's start with the question. Now in this question, function is given to us and the graph of the function has a local minima at the point P, Q, and we have to find the values of P, Q. So let's start with the solution. Now in this question, since fx is given, so first we have to find out f dash x, as we are talking about minima point. So my f dash x will be 4 by 3 as it is, x cube derivative is 3x square, 16 as it is, x derivative is 1. So f dash x is 4x square minus 16. Now it says it has a local minima. Since it has a local minima, so we have to put f dash x is equals to 0. That will give me 4x square minus 16 is equals to 0. So I can write it like this. So I can say that my x square is equals to 4, or my x value is plus or minus 2. Once I got two values, now to find p and q, what is given to us is p is greater than 0, that is given to us. Since p is greater than 0, so I have to accept x is equals to 2 as my answer. Hence, I can write that p is equals to 2. Once we got our p value, so to find q, I can replace x as 2 in the function. So it will be 4 into 2 cube divided by 3 minus 16 into 2. So f of 2 will be 32 by 3 minus 32, and on further solving I will get f of 2 as minus 64 by 63, which is nothing but the q value because it is my y value. So I can write as q as minus 64 by 3. So this is how we got our p and q values. Now in this question it says Bob invests 1000 dinar in an account at a rate 4% compounded quarterly. The amount of money in the account after 1 year completion will be written as this, and in the a part we have to find out k value. So let's start with a part. Since I can write this as my amount, that is 1000, 1 plus certain rate to the power t. Now since compounded quarterly is given, so I have to write my rate as r upon 400 because it is being compounded quarterly, and my time as 4t. So my new amount will be 1000, 1 plus r by 400 to the power 40. Now if I compare it with the given term in the question, so I can see that my k value is nothing but r upon 400. So I can write k as r upon 400 and rate is given to me as 4. So k will be 4 upon 400, that is 1 upon 100, or I can write k as 0.01. Now b part says expand and simplify 1 plus x to the power 4. Now to solve b part, we can normally write 1 plus x to the power 4 as 2 into 2. So I can apply a plus b whole square, that will give me this. And now in this I can apply a plus b plus c whole square, which will lead to 1 plus x to the power 4 plus 2x whole square plus 2 times 1 into x square is x square, plus x square into 2x will be 2x cube, plus 2x into 1 is this. It means if I further simplify, I will get 4x square plus 2x square, 4x cube plus 4x. So on simplification and after rearranging, I will get 1 plus x to the power 4 plus 4x cube plus 6x square plus 4x as my answer. Now let's move to C part. In C part it says find the amount of money in the account after completing 1 year. So for C part we can use the given expression as 1000 1 plus k to the power 4. I already got my k value as 0.01 to the power 4. So it will be 1000 into 1.01 to the power 4, and now you can solve this and we will get 1041 as the answer after solving. You can also use binomial theorem, but this is a much simpler way. Now in this question we have to find the area enclosed by the curve y is equals to e to the power x and minus e to the power x in between the lines -1 and 1. Now before solving this question, one thing we have to keep in mind that curve of e to the power x is always like this. It's always like this, and curve of minus e to the power x will be the reflection, which I can draw like this. So if we keep this into mind, then it will be easy for us to solve this question. Now we can find out the area using the formula y2 minus y1 dx, and your limits will be from x1 to x2. So if I apply the formula, my lower limit is -1, upper limit is 1, y2 will be e to the power x and y1 will be minus e to the power x dx. Now I will further solve this. So it will become 2 e to the power x dx, which will be 2 integration e to the power x dx from -1 to 1. So area will be 2 e to the power x integration is e to the power x only, and I will write my limits. Now if I substitute the limits, so upper limit is 1 minus lower limit is -1. So it will be 2e minus 1 upon e, and on further solving we can write it as 2e minus 2 by e or 2e minus 2e to the power -1. Both are acceptable answers. Now this is a question of conditional probability where we are given with these two conditions and we have to find A intersection B. Now because it's written like this, so I got to know that it is a conditional probability question. So let's start by solving A part. So since PB/A is given to me as 2 by 3, so I will use the formula as A intersection B divided by probability of A. Now I have to find A intersection B, and to find A I can apply this formula because I am given with P dash A, which is 3 by 4. This is PA. So if I further solve this, I will get 1 by 4. Now I will just be substituting the values. Let me name this equation as equation 1. So I can put this as 2 by 3. PA intersection B I need to find, and PA is given to me as 1 by 4 after solving. So if I further solve this, my PA intersection B will be 1 by 6. So this is how I got A part answer. Now B part says show that the events A and B are independent. Now to show these events independent, first I will use this formula. PA union B is nothing but PA plus PB minus PA intersection B. Now why I am using this? Because I want to first find out probability of event B. So A union B is 3 by 4 given to me. PA I have calculated in A part as 1 by 4. PB I need to find, and PA intersection B is 1 by 6. I have taken it from A part. Now if I solve PB, it will be 3 by 4 minus 1 by 4 plus 1 by 6, which is nothing but 4 by 6. So On further solving, I will get PB as 2 by 3. Now since it says we have to show that the events are independent, so I will again be using this formula. This is nothing but PB, or since the events are independent, it means PA into PB should be equals to 1 by 6. So now I can say that intersection B is PA into PB, hence the events are independent. Now in this question it says consider a sequence of 10 rectangular pictures of frame starting from F1 ending on F10. The width is 4 and the height is 5 cm. The width and height of the picture is increased by 50% to generate the width and height of the next picture, that is Fn plus 1. Now A first part says show that the area of the picture frame is this. So let's start. Area for this question will be width into height, that is 4 into 5, 20 centimeter square. Now since it says it is increased by 50%, so I can say that my new area will be, it will be increased by 1.5 for width as well as 1.5 for length. So that will be 20 into 2.25. 2.25 is nothing but 9 by 4. So on simplification we got our new area as 45. Now the important thing here to note is from this calculation we got our common ratio as 9 by 4. So for the first part, I can use A as 20 and common ratio as 9 by 4. So I can apply UN formula. So UN formula, and I can write it as Fn A r to the power n minus 1. So my A is 20, r is 9 by 4 to the power n minus 1. So this is how I can say that this is my new area in centimeter square. Now for the second part it says find the mean area of the 10 picture frames, and we have to give our answer in this. It means we have to find out P value. Since it is talking about mean area, so for mean area I have to apply first the sum formula. So mean means I have to first find sum of the first 10 pictures and divide them by 10. Since I have A and R, so I can easily find S10. S10 will be nothing but A r to the power 10 minus 1 upon r minus 1. My A is 20, r is 9 by 4 to the power 10 minus 1 upon 9 by 4 minus 1. Now I cannot change this, so I will keep 9 by 4 as it is. So this will be 20, 9 by 4 to the power 10 minus 1 divided by 5 by 4, and on simplification we will get 16, 9 by 4 to the power 10 minus 1. Since I got my S10, so I can use this mean. So I can write mean as 16 upon 10, 9 by 4 to the power 10 minus 1, which is nothing but 8 by 5, 9 by 4 to the power 10 minus 1. So now if I compare this with the question, so my P value is nothing but 8 by 5, and this is how they have asked to write in. Now in this part it says find the median area of the 10 picture frames, and we have to give our answer in this form. Since there are 10 picture frames, so I can write that my median is the sum of 5th and 6th picture divided by 2. So I can use the same formula with same A and R. I can write A6 as 20, my R was 9 by 4 to the power 5, and I can write A5 as 20, 9 by 4 to the power 4. I will substitute this in the above formula. and I can take 9 by 4 to the power 4 common. I will get 1 plus 9 by 4, and it was whole divided by 2, which will give me 10. 9 by 4 to the power 4, 13 by 4, which will be equal to 65 by 2, 9 by 4 to the power 4. And now if we compare it with this, I got my Q value as 65 by 2. Now in this question, the line L1 has vector equation this and L2 has vector equation this, and the condition given to us is that these two lines are perpendicular and intersect at a unique point. Using these two conditions, we will find values of A and B. So first of all, we have to first write the direction vectors of both the lines. So I will write direction vector of line 1 as 0, A, K. Direction vectors are those which are written with this lambda and mu. And for L2, it will be 1, 2 and 3. Now since it is given that L1 and L2 are perpendicular, so I can use my condition as dot product of these two should be equals to 0. So I will do 0, A, K, dot 1, 2, 3, that should be equals to 0. Now this will be 0 plus 2A plus 3 is equals to 0. So my A value will be minus 3 by 2. Now I have to find the value of B. To find the value of B, it is given to me as that they intersect at a unique point. Now when they are intersecting at a unique point, it means their x coordinates, y coordinates should be equal. So if I equate x coordinates, I will get this, and if I equate y coordinate and I am putting A value also for y coordinate, I will get this as second equation, and to equate z coordinate, I will get this as my third equation. Now on solving this, we will get mu is equals to 3, lambda is equals to minus 4, and b is equals to 14. So this is how we got our A and B value. Now in this question, we are given with the complex number 3 to the power I minus 1, and we have to write it in e to the power a form. So let's start with A part. Since z is given to me as 3 to the power I minus 1, I can write it like this, which is nothing but 1 by 3 into 3 to the power I. Now I have to write this 3 to the power I in Euler form or e to the power form. So 3 to the power I can write as ei to the power ln 3, and if I use complex number, so I can write it as cos ln 3 plus I sin ln 3. Now if I substitute this in this, so my complex number z will be 1 by 3 cos ln 3 plus I sin ln 3. So this is how I can write. Now for B part, it says giving your answer in P cos ln Q form, find out real part of z and real part of 1 upon z. So to solve B first part, the real part of z according to A part answer will be cos ln 3 divided by 3. Now if I compare with this cos ln Q, so I can say that from these two comparison that P is 1 by 3 and Q is 3. Now to do B part, real part of 1 upon z. First I will find what is 1 upon z. So 1 upon z will be 3 to the power I minus 1, which I can write as 1 minus I by bringing this into the numerator, and again I will be doing the same thing. Now I will change this as cos ln 3 minus I sin ln 3. So real part of 1 upon z will be nothing but 3 cos ln 3. And again, if I compare this with p cos ln q, I will get my p value as 3 and q value as 3 again. Now in this question, Seema claims that n is greater than log n with base 2 and we have to show this. Now to start with this, I can say that my 1 plus log n with base 2 is nothing but log 2 with base 2 plus log n with base 2. So I have changed this 1 to log 2 with base 2, which further can be written as log 2n with base 2 using log properties of log a plus log b equals log ab. Now as it is given that n is greater than log n with base 2, it means 2n should be greater than or equals to n plus 1. Now if I take log with base 2 on both sides, I can write it like log with base 2 n plus 1. Now since log with base 2x is an increasing function, let me write it because this is important point, increasing function. So hence I can say that 1 plus log n with base 2 is greater than log n plus 1 with base 2. Now to solve B part, it says using mathematical induction and the results from part A, prove that her claim is valid. Now for mathematical induction, we have to go to 3 steps. First step is we have to take n as 1. So I have to put n value as 1 in this. So 1 will be greater than log 2 with base 1, which is nothing but 0. So 1 is greater than 0. It means P1 is true. P1 means I have taken n value as 1 and this is true. Now I have to assume the same thing for n is equals to k. So I can substitute n as k and I can write this also, and I am assuming that pk is also true. Now I have to check it. So for checking, I will check for n is equals to k plus 1, that is one value higher than the last one. So I will replace this. So n plus 1 is greater than log 2 with base log k plus 1 with base 2. Now we have proved this using a part. So I can say that k plus 1 is greater than 1 plus log k with base 2 and it is also greater than log 2 with k plus 1. This is from part A. It means her claim is true. Now in this question we have to consider the differential equation, this and the condition, and we also have to use substitution method to show that the solution of this differential equation is this. So let's start by putting y is equals to vx. So first I will find out the derivative of both sides with respect to x. So I will apply product rule. So v as it is, derivative of x is 1 and x as it is, derivative of v is dv by dx. Now my dy by dx is given to me as x minus y upon x plus y. So I will substitute it over right hand side and I can write it as dv over dx. Now here also I can substitute y as vx, x plus vx equals v plus x dv by dx, and I can take out x common from both the sides, numerator and denominator, like this, and I can cancel this out. My right hand side will remain the same and I can take out v from right hand side to left hand side and I can write it like this. So if I take LCM, it will be solved according to this and right hand side will be the same. So on further solving, I will get 1 minus 2v minus v square upon 1 plus v. Now I will separate x terms to one side and v terms to other side. So I will put my x terms to left side, and when I will put my v terms to right side, I will get this. Now I will be integrating both sides. So integration of 1 upon x is ln x. So my main focus is to integrate this. So for this I have to use substitution method. I will assume this as t and I will take derivative of both sides with respect to t. So I can, with respect to v, so it will be 0 minus 2 minus 2v is equals to dt by dv. So I can write dv as dt upon, I can take minus 2 common, 1 plus v. And now I can substitute this dv value and this t into this right hand side variable. So what will be the answer? Left hand side is the same. So this will be integration 1 plus v upon t. dv was dt upon minus 2 into 1 plus v. This will get cancelled out. So I am left with minus 1 upon 2 also taken out common, and I am left with this. Now I can easily integrate and I can write it as ln mod x equals minus half ln modulus t plus c. Now I will use this later also. Now I will substitute t value, which is nothing but 1 minus 2v minus v square, and again I have to replace v also. Since y was vx, so I can write as 1 minus 2 y by x minus y square by x square plus c. Now to find c value, I will use the condition given to me in the question, taking x as 2 and y as 0. I will substitute this. I will get ln modulus 2 as minus half ln. It will be 0 both the terms. So ln modulus 2 as half ln 1 plus c. ln 1 is nothing but 0. So c value is ln modulus 2. I will be substituting this c. I will name this equation as 1 and I can substitute it over here. So I will get my answer as ln modulus x equals minus half ln 1 minus 2y by x minus y square by x square plus ln 2. Now I can take this entire thing to left side. It will be plus 1 by 2 ln 1 minus 2y by x y square by x square, that is equals to ln 2. And now I can apply the product rule, but before that I have to rearrange this again, and I can write it as half ln 1 minus 2y by x y square by x square as ln 2 minus ln x. Now I can bring this half over there and I can apply ln a minus ln b rule as ln a by b into the right hand side. So I can write it as ln 1 minus 2y by x minus y square by x square as ln 2 by x whole square. And now I can compare both sides and I will get my answer as 1 minus 2y by x minus y square by x square as 2 by x whole square is 4 by x square. Now I am just left with rearranging. So I will bring x square over here and I will take x square as my LCM. So I will get 2xy minus y square as 4 by x square. This will get, sorry, this is not here because I have brought it over the right side. So I will get x square minus 2xy minus y square as 4. This is the solution to the equation given to me in the question. Now in this question, the function fx is defined to me as this, and we have to write this in this form. So we can start by using FOIL method, and we can open these two brackets. So I will get x square plus 3x plus x plus 3, that is x square plus 4x plus 3. Now you can use either completing the square or middle term splitting. So I can write it as x square plus 2 times x into 2. Now to get 3, I have to do 4 minus 1. So that will give me x plus 2 whole square minus 1. Now if I open the bracket, I will get 5 into x plus 2 whole square minus 5. Now if I compare this with this thing given to me in the question, that is a x minus h whole square plus k, and on comparison I can say that a is 5, h is minus 2 and k is minus 5. So these are my values of a, h and k. Now the B part of the question says we have to sketch by showing all the values of intercepts and coordinates of the vertex. So I will use my result from A part, that is fx is equals to 5 times x plus 2 whole square minus 5, or we can use the first equation which is given to us as this, and from this I can say that my x-intercept is nothing but minus 1 comma minus 3. As you put these two brackets equal to 0, we will get x-intercept. Now to get y-intercept, we have to put x is equals to 0 into the equation. So when I will put x is equals to 0 into the equation, I will get 15 as my y-intercept. And for vertex, we can use the formula minus b by 2a comma delta by 4a. Delta is nothing but b square minus 4ac, and on putting the values I will get minus 2 comma minus 5. Now with these values I can sketch the curve. First I have to draw x and y axis. Now since I have two intercepts, both are negative, so my graph will go like this, where this point will be minus 3, this will be minus 1. These are my two x-intercept. This point will be 15, and this is my vertex, that is minus 2 comma minus 5, and this is the curve for y is equals to fx. Now let's move to C part. We have to solve the inequality taking fx less than or equals to 40. So to solve this, first I will use my result from A part, that is x plus 2 whole square minus 5, and the condition is given to me as it is less than or equal to 40. Now I just have to simplify this. I will get 45, that gives me x plus 2 whole square less than or equal to 9. It means x plus 2 is less than root 9, or if I can write this as x plus 2 whole square is less than 3 square. 3 square means I am taking plus value also and I am taking minus value as well. So on expanding this, I will get x plus 2 between minus 3 to 3. Now on simplifying it further, I will get x plus 2 as greater than equals to minus 3, or x plus 2 less than equals to 3. So my x will be greater than or equals to minus 5, or x value will be less than or equal to 1. So on combining these two, I can write that my x value lies between minus 5 or 1, or we can also write that x belongs to minus 5 or 1. Both answers are acceptable. Now in D part, function gx is given to me as ln x, and I have to write the expression for this. Since this is a composite function, so I can write f of g of x as f of gx. It means in fx, instead of x I have to put gx values, and gx is nothing but ln x. So basically I have to find f of ln x. So my fx from the question was 5x plus 1 into 5x plus 3. So I have to find f of g of x, so which I can write as ln x plus 1. I am just replacing x with ln x. So this is how I will get this. You can use your result from a part also. Now I have to solve this inequality, the result which I got in the above part. So I will use this result, but first I will write this f of g of x is less than or equals to 40. So if I use my result from C part, which was my x values were lying between -5 to 1. Now I can take log on, I can write -5 is less than ln x for the same value till 1. Now I will convert this log into exponent, so I can write e to the power -5 and x less than equals to e to the power 1. So this is the answer. Now let's move to E part. We have to find the domain of g of f. So to find the domain, first we have to find what is g of f, that is g of fx. My gx was ln x, so instead of x I will write fx function, that is 5x plus 1 into x plus 3. Now to find the domain, we have to be sure that whatever is written inside log, it should be greater than 0. It has to be positive values. Now I can write the critical points or the intercepts as -1 and 3, and to check the sign I will use sign diagram. So I will draw it over here. So this is -3. Now to check for what values of x this function is greater than 0. So I will assume my x value as 0, which is greater than -1. So my function will be 5 times 1 times 3, which is 15, which is greater than 0. It means my function is positive for all values which are greater than -1. Similarly, I will take any value in between -3 and 1. Let's take -2. So this will give me 5 into -1 into 1, which is -1, which is less than 0. It means the function is negative in between -3 and -1. Now let's take another value. Let's take x as -4. So it will result in 25, which is greater than 0. It means for the values which are less than -3, it is going to be a positive function. So from this I can write my domain as -infinity to -3 or -1 to infinity. Or you can also write it like this: x values are less than 3 and x values are greater than 1. Both the answers are correct. Now let's move to the next question. The plane pi1 is given with this equation and plane pi2 is with this. An acute angle between these plane is theta, and we have to show that theta is 60 degree. So let's start by solving. So first of all, we need direction vectors of both. So for pi1 plane, my direction vectors will be the coefficients of x, y and z. So coefficients are 1, 2 and 1 because it is x plus 2y plus z, and direction vectors of plane pi2 will be 1, -1 and -2. Now whenever we are talking about angles, so we will attempt to use scalar product between these two, that is a dot b will be mod a mod b cos theta. So mod a we will calculate later. First let's take the dot product. Mod a will be under root 1 square plus 2 square plus 1 square. Modulus b will be 1 square minus 1 square minus 2 square, and I have to write cos theta now. So this will give me 1 minus 2 root 6. This is also root 6 cos theta. So I am getting minus 3 as 6 cos theta. So cos theta will be minus 1 by 2. Cos theta is negative when my angle is 120 degrees. But the question said acute angle. So for acute angle, I have to do 180 minus theta, that is 180 minus 120, and hence I got my angle as 60 degrees. Now in the next part we have another plane pi 3 which is perpendicular to both pi 1 and pi 2. So you have to remember that whenever we are talking about perpendicular, so we are talking about the normals and they intersect at a unique point R, we have to find the Cartesian equation of the plane pi 3. Since pi 3 is perpendicular, so we will first find the vector product of their normals. Their normals means n3 will be equals to n1 cross n2. So n3 will be I, j, k. I already have my direction vectors 1 minus 1 minus 2 from the first part of the question. Let me solve this. So I can write my matrix as this: minus j times 1 1 1 minus 2 plus k times 1 1 2 minus 1. Now to further solve this, I will get minus 4 plus 1 minus 2 minus 1 plus k times minus 1 minus 2. So n3 is nothing but minus 3i plus 3j minus 3k. Now from this I can say that the direction vector of plane pi 3 is minus 3, 3, minus 3. So I can take 3 common and I can write it as minus 1, 1, minus 1. Once I get the direction vector, I will use the equation of plane A3 as ax plus by plus cz is equals to d, where a, b, c are my direction vectors. So I will substitute minus 3x plus 3y minus 3z is equals to d. Now I am left with finding out the value of d. To find the value of d, it is given to me that it is passing through the point r, that is 5 comma minus 5 comma 5. So I will substitute this into this equation to find d. So that will be 3 into minus 5 minus 3 into 5 equals d. So my d value will come out as minus 45. It means the equation of the plane pi 3 will now be minus 3x plus 3y minus 3z is equals to minus 45. Now we are only left with simplifying, so I can take minus common from all of these and I can write it like this. So my answer will be 3x minus 3y plus 3z is equals to 45. Or if I take 3 also common, I will get my answer as 15. So this is how we will solve this part. Now let's move to the last part of the question. Now both of these plane contains a mirror and a ray is directed towards mirror in pi 1 at angle 45, which meets at point P, and for pi 2 it meets at point Q, and both the points P and Q are contained in pi 3, and it is given to me that PR is 5 centimeter. We have to use appropriate compound angle identity, which you can write from your formula booklet. We have to show this. So let's start by solving C first part. So sin 75 I can write as sin 30 plus 45 degrees. And now I can apply compound angle identity. Sin A plus B is sin A cos B plus cos A sin B. So I can write this as sin 30 cos 45 plus cos 30 sin 45. Now Sin 30 is 1 by 2, cos 45 is 1 by root 2, cos 30, sin 45. Now to further solve this, I will get 1 by 2 root 2 plus root 3 by 2 root 2, which will give me 1 plus root 3 by 2 root 3 as the answer. But still I cannot write this as my answer because question has asked in this form. So I will rationalize both side by root 2. I will get it as root 2 plus root 6 whole divided by 4. This is how I will solve C first part. Now for the second part, it is given that we have to find OR in the form. So what we can use is, we can use sine rule with 75 degree and 45 degree angles in the triangle PQR. You can see the triangle over here, so I can write PR upon sine 75 is equals to QR upon sine 45. Now we have to find QR and PR is given to me as 5. So I can write QR as sine 45 into PR upon sine 75. So this will be 1 by root 2. PR was given to me as 5 and this value was root 2 plus root 6 by 4. Now this just needs to be simplified. Now I will bring this 4 in the numerator, that will be root 2 plus root 6, and my QR will be, if I rationalize this further, or I can first multiply this, I will get root 12, and now I can rationalize it as 2 minus root 12 upon 2 minus root 12. So QR will be 20, 2 minus root 12. In the denominator it is a plus b, a minus b. So I can write it as 4 minus 12. That will give me minus 8. And I can write this root 12 also as 2 root 3. So my QR will be minus 5 by 2, 2 minus 2 root 3. So I can bring this negative inside and I can take out 2 common also. So that will be root 3 minus 1. So my final QR is 5 root 3 minus 1. And in the question it was in the form P root Q minus 1. So from this I can say that P is 5 and Q is 3. Now in this question we have to consider the family of functions, this one, and A part says by writing cos to the power n into x as this, we have to show this result. So let's start. Now in this question, function of x is cos to the power nx. So I have to integrate this by writing it as cos to the power n minus 1x into cos x dx. So we have to use integration by parts to solve this. So to use integration by parts, I have to assume my u as cos to the power n minus 1x and v dash as cos x. So let's first find out the derivative of u, that will be minus n minus 1 cos to the power n minus 2x, and cos x derivative will be sin x. Similarly, since I have v dash, so I need to find v. So I will be integrating cos x with respect to dx. My v will be sin x. Now we have to use the formula, that is integration uv dash dx is equals to uv minus v dot u dash dx. This is the formula for using integration by parts. This is there in your formula booklet as well. So now if I integrate this function where cos to the power n minus 1 x is u and cos x is b dash, so I will be writing RHS only. So my RHS will be, it says u into v, so u will be this and v is my sin x minus integration sin x dot u dash. Now u dash is this entire, so I will be converting minus into plus and then I can write it like this, and at last n minus 1 dx. Now in this we can further simplify by first multiplying these two sin x. So this will be as it is, plus I will be taking n minus 1 common, so I can write it like sin square x dx. Now I can write this sin square as 1 minus cos square x, so the integral will become, this will be the same, plus n minus 1 integration 1 minus cos square x. Now I have to open this bracket, so this will remains the same, and when I will open the bracket I will get cos to the power n minus 2x, plus minus becomes minus. I will again write n minus 1 integration cos to the power n minus 2x cos square x dx. Now my next step is to simplify this. So I can write it as cos to the power n minus 1x sin x plus n minus 1 integration this minus n minus 1 integration cos to the power n dx. This is what the question has asked. Now let's solve b part. We have to show this. Now to show this we will be using a part answer and we will be separating cos to the power n, and we can say that we are rearranging this. So on rearranging a part I can write cos to the power nx dx. Now I can bring this cos function to the right side, so that will become minus n plus 1 integration this, and I will be writing my right hand side here. So cos to the power n minus 1x sin x plus n minus 1 integration n minus 2 x dx. So now in the right hand side I can open the bracket, so it will be cos to the power nx dx plus n integration this minus integration this, and my right hand side will be the same. So I will copy it as it is, integration cos to the power n minus 2x dx. So now as you can see these two will get cancelled out, and I can take this n also to the right side. So integration cos to the power nx dx is equals to 1 upon n cos to the power n minus x sin x plus n minus 1 upon n integration cos to the power n minus 2x dx. Now as in the question it is given that fx with base n is my cos nx, so from this I can write cos to the power n minus 1 x as fx to n minus 1. Similarly n minus 2 will be written as fx to the base n minus 2. So now if I substitute this into these two places, I will get my answer as fx dx is equals to 1 upon n. So here no need to replace because it is as it is in b part. So I will be replacing it here. Integration fn minus 2x dx. So this is how we will solve b part. Now in c part we have to find an expression for cos to the power 4x. So we will be using the result of b part answer, that is 1 upon n cos to the power n minus x sin x plus n minus 1 upon n integration fn minus 2x dx. So I can write cos to the power 4x dx as 1 upon 4 cos cube x sin x plus 4 minus 1 upon 4 integration cos square x dx. So this is nothing but 1 upon 4 cos cube x sin x plus 3 upon 4 integration cos square x dx. Now I have to solve this. So to solve this, I will again be using result of my b part. So I can write it as 1 upon 4 cos cube x sin x plus 3 upon 4 as it is, and I can write it as 1 upon 2 cos x sin x plus 2 minus 1 upon 2 integration cos to the power 0x, which is nothing but 1. So 1 upon 4 cos cube x sin x, so this will be 3 by 8 cos x sin x plus 3 by 8 integration of constant is x, and I will be writing one c also. And the answer was in the form p cos cube x sin x plus q cos x sin x plus rx plus c. So on comparing these two, I can say that my p is 1 upon 4, q is 3 upon 8, and r is also 3 upon 8. Now in the next part, the region R is enclosed by the graph of fx equals cos square x from minus pi by 2 to pi by 2, and it says that this region is rotated by 2 pi radians around the x-axis to form a solid of revolution. We have to find the volume of the revolution. So we will be using volume formula, that is in pi integral y square dx, and since my limits are from minus pi by 2 to pi by 2, and y function is given to me as cos square x, so it will be cos square x whole power x, limits will be from minus pi by 2 to plus pi by 2. So it means I can write it as my limits will be this cos to the power 4x. Now we have already expanded cos to the power 4x in c part, so we will be using c part result. So I can write my volume as pi cos cube x sin x divided by 4 plus 3 sin x cos x divided by 8 plus 3x by 8, and the limits are from minus pi by 2 to pi by 2. Now I'm just left with substituting the limits. So when I will substitute the upper limit, it will be cos cube pi by 2 sin pi by 2 plus 3 by 8 I can write sin pi by 2 cos pi by 2 plus 3 by 8 into pi by 2. This is my upper limit minus pi times cos cube minus pi by 2 sine minus pi by 2. Now I am substituting the lower limit. Sine minus pi by 2 cos minus pi by 2 plus 3 by 8 to the power minus pi by 2. Now using pi by 2 values of sin x and cos x, I can write this volume result as this term will be 0 by 4 plus 3 by 8 into 0 plus 3 pi by 16 minus pi times again 1 by 4 into 0 plus 3 by 8 into 0 minus 3 pi by 16. So on further solving, we will get 3 pi square by 16 plus 3 pi square by 16. So my volume becomes 3 pi square by 8. Let's move to E part. So find the Maclaurin series of fx up to x square. So to solve this, first I will write what was my fx with base n. So this is my fx. So for that, first I will take its first derivative, that is n cos to the power n minus 1 x into cos x derivative, that will be minus sin x. If I again take the derivative, so I will get minus n cos to the power nx plus n into n minus 1 cos to the power nx into sin square x. Since I have used product rule, so that's how I have solved. Now to find the Maclaurin series, I want the values at 0. So f0 becomes 1 and f dash 0 will also become 0, but f double dash 0 will become minus n, because sin 0 is 0 here, sin 0 is 0, and here cos 0 is 1, so that's how we are getting. So now using the Maclaurin series expansion, I can write that my function is 1 plus 0 times x minus n times x square by 2 factorial and so on. So on simplification, I will get my answer as nx square by 2 plus so on. So this is the binomial Maclaurin series for this function. Now to solve E second part, we have to find the limit. So for the second part, I will be using result of E first part. So I can write limit x tends to 0, my fx was 1 minus nx square by 2 plus so on minus 1 whole divided by x square. That will lead to minus nx square by 2 whole divided by x square, that is nothing but minus n upon 2. So I got my limit in terms of n. Alright, that brings us to the end of this paper 1 solution. If this solution helped you understand the concept and exam approach, do give the video a like. If you have any doubts or would like to see more IB past year questions, feel free to leave a comment below. Don't forget to subscribe to IB Methodology for more clear and exam focused IB math content. Thank you for watching, and I'll see you in the next video.